This is Tropicana Field in St. Petersburg, Florida, a $130 million domed stadium with 6 acres of fiberglass roof held up by 180 miles of steel cable, and on the 9th of October, a hurricane tore it to ribbons. 7 months before that storm, the city voted to cut the stadium's windstorm insurance from $100 million to $25 and saved itself $275,000 a year. So what did that $275,000 actually end up costing? This is Project Breakdown, where we investigate the world's most ambitious structures and the engineering failures that brought them down. New investigation every week. This 6-acre Teflon-coated fiberglass roof was built to shield the stadium and reduce cooling costs. Yet 7 months before the storm, the city slashed its storm insurance limit from $100 million to $25 million. When Hurricane Milton struck in October 2024, the aging fabric shredded. Completely. The disaster left a $57 million repair bill against a $22 million deductible. Still, the city must rebuild, because lease agreements legally bind them to provide a functional dome until the team departs in 2028. On 7 March 2024, municipal officials trimmed $75 million from the property insurance program for the dome. They lowered the named windstorm and flood coverage ceiling from $100 million down to $25 million. In plain terms, the coverage ceiling is the maximum amount an insurance company will ever pay out for a disaster. Beneath that ceiling sat a separate deductible of $22 million, the initial damage bill the city had to cover entirely out of pocket before receiving a single dime of insurance money. By shrinking their safety net, officials saved $275,000 in annual premiums. In a major municipal budget, that is pocket change, roughly equivalent to buying one fully loaded, heavy-duty commercial pickup truck. 7 months later, Hurricane Milton tore through the region. The storm left behind a ruined structure and a repair bill that quickly climbed past $55 million. For scale, $55 million is enough money to construct a small municipal concrete bridge from the ground up. Because of the March decision, the math was brutal. With a $22 million deductible and a $25 million ceiling, the actual insurance payout was capped at just $3 million. The city was left to fund the rest of the massive gap. It was a classic financial gamble that went catastrophically wrong. But this lopsided ratio raises a deeper engineering question about the building itself. Why did a fabric roof warrant a $100 million insurance policy in the first place? The stadium opened on 3 March 1990 as the Florida Suncoast Dome. Building it cost the city $130 million, a massive sum, roughly equal to the price of pouring 40 standard concrete highway interchanges in that era. Yet, when the doors opened, the stadium was completely empty. St. Petersburg had built a massive arena without a Major League Baseball team to play inside it, a civic gamble designed to lure a future tenant to the coast. That tenant finally arrived in 1996, and the building was renamed Tropicana Field. Sitting inside, fans did not look up at steel trusses or open sky. Instead, they sat beneath 6 acres of translucent, Teflon-coated fiberglass membrane, an overhead canopy larger than 4.5 football fields stitched side by side. The entire stadium was organized around this single, continuous sheet of fabric. Unlike a conventional ballpark where a roof is added to cover the seats, this building was engineered specifically to support its ceiling. This choice served a practical purpose. What exact engineering problem was this strange fabric ceiling designed to solve? The roof does not sit flat. Instead, it slants sharply downward, descending from an apex of 225 feet above second base to just 85 feet at the center field wall. This lopsided geometry was a calculated response to the harsh Florida environment. By cutting off the empty space above the outfield, engineers reduced the stadium's internal volume by a massive margin. Cooling a traditional level dome in the summer heat is like air conditioning an airplane hangar. This tilted profile spared the municipal utility budget from constantly cooling millions of cubic feet of empty air. Apart from thermal efficiency, the slope served a structural purpose. Rather than presenting a broad, upright target to incoming tropical systems, the slanted canopy was designed to let hurricane winds slip over the top, reducing wind-up lift forces and helping the building withstand forces of 115 miles per hour. This geometry was a heavily considered design decision, treating the stadium's profile as an active aerodynamic shield rather than an ornament. But draping a massive, sloping sheet of fabric over a Major League Baseball field presents an immediate engineering crisis. How could a fabric canopy remain stable and rigid under extreme wind loads without a single interior support column to hold it up? The roof functions as a tensegrity network. Inside this giant web, steel cables pull under tension, while heavy metal struts push outward, holding the massive net apart. The translucent fabric itself carries almost none of the main structural load. Its primary job is simply keeping the wind and rain out. This system relies on 180 miles of cable and struts. That is long enough to drive from Tampa to Orlando, turn around and head back, and then make that exact same 90-mile highway trip one more time. When brand new, this system carried a certified wind rating of 115 miles per hour. But there was a catch. The manufacturer designed the fiberglass membrane to last for only 25 years. By 2024, the roof had baked in the brutal Florida sun, high humidity, and salty coastal air for 34 years without a single full replacement. This relentless exposure left the outer protective coating brittle and worn. According to David Campbell, a principal engineer at Geiger, this envelope was operating well past its design service life. This raises an obvious question for any builder. When the city evaluated its disaster exposure, did they base their calculations on a brand new roof, or did they account for a decaying 34-year-old fabric? On 7 March 2024, the city's Budget, Finance, and Taxation Committee gathered to decide the financial future of the dome. The meeting moved quickly, ending in a unanimous vote. Senior Vice President Tony Levine presented the formal recommendation from the broker, Brown & Brown. Their plan was set to take effect on 1 April 2024, completely restructuring the stadium's risk profile. Under these new terms, the city established a $25 million coverage ceiling for named windstorms and floods, a sum equivalent to buying a fleet of 80 heavy-duty concrete mixer trucks. Directly beneath this sat a $22 million deductible, which is roughly equal to the cost of pouring 20,000 cubic yards of structural foundation concrete. This arrangement yielded an immediate premium saving of $275,000, a sum that could purchase a brand new commercial diesel excavator. To reassure the committee, risk manager Blaise Mazzola stated that the lower limit was more than enough to protect the park, asserting the roof could withstand a 250-year storm. This rationale made sense on paper, supported by professional broker advice and a structural design rated for 115 miles per hour. But while this vote reshaped the city's financial exposure, it did not physically alter the aging fabric overhead. How would the actual storm test this paper-thin mathematical forecast? On 9 October 2024, Hurricane Milton made landfall on the Florida coast as a Category 3 storm. While local weather stations recorded peak regional gusts of 115 miles per hour, the real disaster unfolded at the damaged edge of the stadium's roof. At approximately 2:30 in the morning, the windward perimeter of the 34-year-old fabric ruptured, creating an entry point for the elements. Once high-velocity wind got beneath the tensioned membrane, it acted like a giant sail, creating a severe pressure imbalance. This aerodynamic force pulled and peeled adjacent panels, causing a progressive tearing cascade that zipper-ripped across the connected material. By 3 in the morning, 6 acres of Teflon-coated fiberglass, an area larger than 24 typical suburban home lots, were reduced to tattered ribbons. While the storm completely shredded the fabric, the massive cable and strut tensegrity framework remained structurally sound and largely intact, holding its shape above the empty field. The disaster also forced a swift relocation of the Florida National Guard and emergency teams who had been using the dome as a post-storm staging area. Fortunately, emergency management reported 0 injuries among the staff on site. But with the stadium interior suddenly exposed to the open sky, what does a major league ballpark actually become when its weather barrier disappears? The physical damage extended far past the roof itself. Without its fabric shield, the concrete bowl turned into a massive funnel, directing torrential Florida rain straight onto the playing field and seating areas. The internal drainage network, designed to handle only minor condensation and routine cleaning, was instantly overwhelmed by open-sky downpours. Water surged past the drains, seeping directly into lower-level concession stands, electrical panels, and heavy ventilation systems. Tattered fiberglass and sharp cable debris littered the stands, lights, and concourses, turning a sports arena into a hazardous industrial cleanup site. Securing, drying, and inspecting the thousands of high-voltage electrical lines and saturated mechanical systems became a monumental task. The ballpark was completely stripped of its secure, dry occupancy, leaving behind an unusable shell. It took a demanding 4-week cleanup effort, a massive undertaking akin to clearing a major road landslide with basic heavy diesel earth movers, just to stabilize the structure and make it safe for inspectors. Yet, with the facility now open to the elements and the team displaced, a more critical problem arose for the taxpayers. How does the sudden loss of a building's primary function translate into a massive public capital bill? On 31st October 2024, the City Council approved an initial $6.5 million just to clean up debris and stabilize the exposed structure. That baseline sum, which could purchase a fleet of over 20 heavy-duty diesel excavators, was only the first spending bucket. By April 2025, the city authorized a separate $22.5 million contract specifically for the replacement roof fabric. This second bucket, equivalent to pouring 20,000 cubic yards of structural foundation concrete, sent the total projected recovery cost climbing past $55 million and eventually over $57 million. The actual insurance math offered little relief. While a $22 million deductible had to be paid out of pocket, the city's exposure was capped by the $25 million coverage ceiling. This left millions in repairs completely uninsured. Recognizing this vulnerability, the council adjusted their policy in March 2026, raising the named storm coverage ceiling to $50 million. This safety net cost an additional premium of $125,000 per year, about the price of a single heavy-duty commercial pickup truck, and roughly half of what they had originally tried to save. With $57 million on the line to fix a 34-year-old dome, taxpayers faced a baffling riddle. Why did the city commit millions to rebuild a stadium whose primary professional tenant was already preparing to pack up and leave forever? For the entire 2025 season, the Rays relocated to George M. Steinbrenner Field, an open-air spring training facility in Tampa. This move shrank their home game capacity from over 43,761 seats down to just 11,000, a squeeze that turned baseball operations into a logistical puzzle. Faced with a ruined venue, the city weighed a 3-option decision matrix. First, leaving the building shuttered. Preliminary municipal feasibility reports estimated this route would cost $600 million, equivalent to fabricating over 500,000 tons of structural steel over 7 years, while instantly violating lease obligations. Second, building a permanent new roof structure. City architectural assessments projected a full-scale rebuild at $1 billion, roughly equal to pouring 900,000 cubic yards of foundation concrete, with no verified timeline. The third option, repairing the existing fabric, was estimated by lead contractors Hennessy Construction and Ecom Hunt at $55 million, roughly the price of 500 commercial diesel trucks over 13 months. Repair offered speed, lease compliance, and a swift return to baseball, making it the only practical choice. But as workers prepared to patch the old dome, a final question remained. Why spend millions restoring a stadium whose tenant is already scheduled to move into a brand new home in 2028? According to a report by NPR News, a single parallel to this fabric failure occurred at the Hubert H. Humphrey Metrodome in Minneapolis. In December 2010, approximately 15 inches of heavy snow loaded the dome's aging tensile roof, tearing the membrane and causing a rapid collapse. The life cycle lesson from Minnesota was clear. When a lack of monitoring and maintenance combines with worn material, minor changes in load and tension easily push a membrane outside its intended safety margin. At Tropicana Field, workers raced to beat the clock. The replacement roof was finished ahead of schedule in November 2025, and the Rays returned for the 6th of April, 2026 season opening. Yet, even with a fresh ceiling, the team still plans to leave for a new Tampa stadium in 2028. Ultimately, the engineering concept of the tensegrity dome held up better than the city's life cycle and insurance arithmetic. While the premium cut did not physically cause the fabric to tear, it exposed a fragile financial structure. With millions spent to repair a dome scheduled for demolition in just 2 years, it raises one final, glaring question. What does restoration actually mean when the building's entire future remains temporary? In the end, municipal risk assessment must always reconcile with the physical reality of coastal weather. When the storm clears, the ledger remains as a stark warning for every public asset. $275,000 a year against $55 million, and a season played somewhere else. Thanks so much for watching. This is Project Breakdown. If you enjoyed this investigation, hit the like button and subscribe, and there will be a new megastructure breakdown next week. Until the next one, subscribe for the next megastructure breakdown. Today, municipal planners face a changing climate with budgets designed for a calmer past. The empty, soon-to-be demolished dome is a stark reminder of what happens when financial caution overrides physical preparation. When the next storm makes landfall, paper savings cannot shield concrete assets. In the collision between municipal balance sheets and coastal reality, physics always has the final, most expensive word.